Hello everyone, I'm Alexander Fricas and joining me is Jason Smith. Today we'll walk you through our proposed Green Infrastructure Retrofit for Stormwater Management at Liberty University. Over the next 10 minutes, we'll explain why the campus needs a proactive solution, how our hybrid design of bioretention cells and permeable pavement works, and the economics and environmental benefit it delivers. We appreciate your time and look forward to your feedback. Here's how we organize the talk. First, I'll summarize the project and goals and introduce the problem. Then I'll cover the background, research, and the technical analysis that led us to our chosen design. Jason will present our recommended implementation plan, discuss professional ethics, and close with key takeaway. We'll finish the Q&As where the two of us can address your questions. Liberty University expansion has dramatically increased impervious surface, which in the future storm event could overwhelm existing drainage, create flood risk, and degrade water quality. Our hybrid green infrastructure solution pairs bioretention cells with permeable interlocking concrete pavement. Modeling shows we can cut peak-off runs off about 55%, and a life cycle analysis demonstrates we can save roughly $310,000 versus simply enlarging curb and gutter system. Because the design is modular, we can install it in phases starting in 2025 without disrupting daily campus life. Over the past decade, Liberty University added new resident halls, parking decks, and pedestrian corridors. Those hard surfaces don't let rainwater soak into the ground. Instead, water flows quickly to inlets that were sized for a smaller campus. Using GIS, we map impervious growth and fed those areas into HydroCAD to forecast runoff under a 2-year design storm. Areas like the dining hall parking lot could nearly double flow rates, surpassing pipe capacity. Acting now before failures occurs, protect infrastructures, and support the university sustainability mission. Green infrastructure has a solid evidence base. Bioretention cells, essentially engineer rain gardens, capture runoff, filters pollutants through soil media, and let clean water infiltrate or drain slowly. Studies cited by the EPA report 50 to 70% reduction in peak flow and similar pollutant removal. Permeable pavement like PICP allow water to pass through joints into a stone reservoir, storing up to a foot of stormwater. Long-term monitoring shows GI often costs less than traditional upgrades because it reduces pipe maintenance, extends pavement life, and provides ecosystem service like urban heat mitigation. We compare 3 alternatives. Option A, expanding curb and gutter, costs about $380K and still funnels polluted runoff downstream. Option B, standalone bioretention improves quality but doesn't fully address volume. Option C, or hybrid, costs only $295K and meets Virginia DEQ flow targets. HydroCats show peak discharge from the dining hall lot drops from 0.19 to 0.085 meters per second over 30 years. Factoring inspections and vacuum suite maintenance, the hybrid total $510,000K, the lowest net present cost and yields a benefit cost ratio of 2.4.
Hello, my name is Jason. Let's jump into some recommendations and phasing. I'm going to be taking you through the rest of this presentation, so let's get started. Let's look at our timeline first. As we can see here, our design permitting is this fall, and construction is going to go through January to July of 2026 while the students are away. This is going to be starting phase 1 right now. We're going to want to implement the 40 square meter bioretention cells with the interlocking cells as permeable pavement at the dining hall, which is about 2,600 meters square. If this works, then we're going to try and put this out to other parts of the campus to reduce costs and repairs over time. Looking at the ethics and impacts, let's ask ourselves why these bioretention cells, the interlocking pavement that's permeable to water, is so great for sustainability but also ethics. First of all, the American Society of Civil Engineers Code of Ethics calls us to protect the health, safety, welfare while advancing the sustainability and development of our infrastructure. What we're trying to do here is create a design that mitigates flood hazards, improves the water quality, and optimizes the ecology and the environment for the animals around us, as well as the social context and the pollution around us to keep everything, not just us, well and in good working order. This also supports the UN Sustainability Development Goals 6 through 11 by promoting clean water and resilient cities. The early implementation of a campus with bioretention cells with a walking area that is permeable pavement is a really good look on the international stage for Liberty. So looking in at Liberty from an international point of view, we can see that their green infrastructure is not only cost effective, it's also environmentally friendly, and it is a game changer for Liberty's social media and marketing campaigns. It's a great thing overall. We've got 55% of the stormwater runoff, peak runoff, being saved, and the university could save an estimated 310,000 US dollars over its lifetime. So we look at everything we've covered, we see that beginning 2025, Liberty will begin the resilient, scalable solution of putting these bioretention cells, permeable pavement across the campus if the implementation of Phase 1 goes well. This will put Liberty in the forefront of sustainable campuses in the United States. With this in mind, we are very excited to move forward with stakeholder agreements and investment holders to bring all of the phases online and implement this structure as soon as possible to be leaders of health, safety, well-being, and sustainability of the future of America. So thank you for joining us today. I appreciate you watching and learning with us. If you have any questions, ideas, alibis, or inputs, please put them in the comment section below, and we'll get to them as soon as we can. Thank you.